Morning children. So welcome back to the online session of a mathematics class. So we are discussing about the lesson number system. So in that we are discussing about law of exponents for real numbers. So I had explained what are the laws of exponents we have for general number system. So in that what are the laws we can able to apply for the real numbers in the last video. And we have solved some of the examples also. So I have given some homework also to do that. Okay. So we will continue the lesson. Same exercise 1.6. So in that first second main fine. Fourth one I have to do that. Okay. So fourth one 125 to the power of minus 1 by 3. Minus 1 by 3. So if I am having a positive power, then how to do that? I have explained in the last session, right? So if I am having a negative number, then how to do that? That we will see in the today's class. Okay. Again, we will be having 125 to the power of minus 1 by 2. We will do it as usual in the earlier method. That is 125. Write the factors for 125. So it is 125. So you need to find out the factors. So it is not divisible by 2. Why it is not divisible by 2? Because the last digit is 5, which is odd number, which is not a even number, so it is not divisible by 2. So whether it is divisible by 3, so it is to divisible by 3. If you add the digits, that must be divisible by 3. 2 plus 1, 3, 3 plus 5, 8. 8 is divisible by 3? No. That means this number is not divisible by 3. You have learned the divisibility condition in class 6 itself, right? What is the divisibility condition for 2, divisibility condition for 3, divisibility condition for 5, divisibility condition for 4 also. So everything you have studied that, right? So we need to divide by prime numbers only. So from the 2 it is not possible, from 3 it is not possible. We have to divide by next prime number. Which is next prime number after 3? 5. So you need to try with 5. Since I am having last digit is 5, it is divisible by 5. The last digit is 5 or 0, then it is divisible by 5. So 5 2s are 10, 2 will be remaining, 5 5s are 25. Again it is divisible by 5, 5 5s are 25. Again it is divisible by 5, 5 1s are. So 125 I can write as 125 to the power of minus 1 by 3, can be written as 125 I can write as 5 into 5 to the power of minus 1 by 3, correct? So 125 are written in terms of factors, that is in terms of 5 into 5 into 5. That I can write as 5 to the power of how many times? Multiplied 3 times. So 5 to the power of 3. So this is 3 is 5 is multiplied thrice 3 times. So what is the power? We will write as it is minus 1 by 3. So now we need to apply the law of exponent. So which law are we going to apply? That is a to the power of m whole to the power of n is equal to a to the power of m into n. This law we need to apply because 5 is the base, 3 and minus 1 by 3 are the powers, 2 powers. Here also a is the base, m and n are powers, a to the power of m whole to the power of n. So what will happen? Base, those 2 powers will be multiplied. Those 2 powers will be multiplied. So we will write the base as it is 5. So 3 into minus 1 by 3 that will multiply. Power that will multiply. 3 into minus 1 by 3. So 3 in the numerator, 3 in the denominator will get cancelled with the power. Okay. So 5. Okay. So 1 into minus 1 divided by 3 ones, right? In the denominator we have 1. That is in the power. Okay. So which will be, if you divide minus 1 by 1, it is minus 1 only. If you divide anything by 1, you will be getting anything only, right? 3 divided by 1 is 3, 4 divided by 1 is 4. You divide whatever number by 1, you will be getting the number itself. Okay. So this is 5 to the power of minus 1. If you want to write in terms of plus power, so 5 to the power of minus 1 percent, it is nothing but 1 over 5 to the power of plus 1. Correct? 5 to the power of minus 1 percent, 1 over 5 to the power of plus 1. If you send to the denominator, the power will become plus. Similarly, if you bring from the denominator to the numerator, power will become negative, minus. Okay, so this 1 over 5 to the power of 1 is 5. Okay, that is 1 by 1 will be the answer for this. Okay, understood this? If you have a negative sign, so keep that negative sign as it is, simplify that. So that since it is having a negative sign, that we should write in the denominator reciprocal 1 over 5 to the power of 1. Then according to the power, if it is 5 to the power of 2, then multiply 5 2 times, then write the answer 1 over 25. Because here it is 5 to the power of 1, it is only 5. Because 5 to the power of 1, nothing but 5. Okay, both are same. Now we go for the third method. Simplify. First one, 2 to the power. First one, 2 to the power of 3 by 5 into 2 to the power of 1 by 5. 2 to the power of 1 by 5. So we need to simplify this. We will see how to simplify this. Okay. Normally, whenever there is an integers, we know that 2 to the power of 3 into 2 to the power of 5. So to simplify this, bases are same, is multiplied. So write the base, add the powers, correct? So 2 to the power of 3 plus 5. The answer is 2 to the power of 8. So multiply 2 8 times, then write the answer. Okay. So that is the method, right? The law of exponents. That is which law? First law. A to the power of m into a to the power of n can be written as a to the power of m plus n. Right? Here also the same concept only, but the power will be a rational number. That's it. Power will be a rational number. Whereas here is the power is a natural number. Here it is power is a rational number. That's it. But the method is same. Same law you are going to apply. Bases are same. It is multiplied. Powers are different. So do the same method. Write the base, add the powers. We'll see what will happen. Write the base. Okay. 3 to the power of 5 plus 1 to the power of 5. Because a to the power of m into a to the power of n can be written as a to the power of m plus n. First law of exponent. Okay. So write the base. So in the power, you can observe that denominator is same, common denominator. So how to simplify that? If it is common denominator, write the common denominator, add the numerators. 3 plus 1. Correct? If it is same denominator, what we will do? We will write the common denominator as 5, then we will add the numerator. If I am having a plus, if I am having a minus, then I will subtract. Okay? Next step. So 2, 3 plus 1, 4 in the denominator. Okay. So it is 2 to the power of 4 by 5. That's it. You can't able to simplify further, you will write as it is. 2 to the power of 4 by 5 will be the answer for this. Okay. So we'll go for the next one. Second one. It is 1 by 3 to the power of 3, then whole to the power of 7. Whole to the power of 7. Okay, we'll simplify this. One by 3 to the power of 3, then whole to the power of 7. Whole to the power of 7. So this power 7 will be there for numerator also as well as the denominator also. This power I can split to the numerator as well as the denominator. We know that a by b to the power of m can be written as a to the power of m divided by b to the power of m. This power will be split for both numerator as well as the denominator. Okay, this is also one of the law. Here also the same concept. This is numerator, this is denominator. Correct? The power is 7. So 7 should be split for 1 also. 7 should be split for 3 to the power of 3 also. Okay? We'll do that. So this is 1 to the power of 7. Denominator I am having 3 to the power of 3. Whole to the power of 7. 7 is splitted. 7 is splitted for both numerator to the denominator. Denominator is 3 to the power of 3. For that power is 7. The reason is a by b to the power of m can be written as a to the power of m divided by b to the power of m. Correct? Okay. 1 to the power of 7 is 1. You multiply 1. How many times you want? Answer is 1 only. 1 into 1 into 1, 1. 1 into 1, 1. 1 into 1 into 1 into 1 into 1. How many times you want? You take it? 1. 1 to the power of 7 is also 1. 1 to the power of 1000 is also 1. 1 to the power of 10,000 is also 1. Okay? So that is 1. 1 to the power of 7 is 1 only. So this is 3 to the power of 3 whole to the power of 7. So which guy are going to apply? A to the power of m whole to the power of n, which can be written as a to the power of m into n. Correct? A to the power of 3 whole to the power of 7. 3 is base, these two are the powers. Correct? We will do that. We will multiply that. So 3 is the base, power is 3 into 7. Correct? A to the power of m whole to the power of n can be written as a to the power of m into n. 3 to the power of 3 into 7. Okay. 1 over 3 base 7 into 3 20. That's it. If I bring 3 to the power of 21 to the numerator, it will become 3 to the power of minus 21. So we will write as it is 3 to the power of 1 over 3 to the power of 21. Will be the answer. Okay. So this is good. Second one. We'll go for third one. Okay. So third one is 11 to the power of 1 by 2 divided by 11 to the power of 1 by 4. 11 to the power of 1 by 2 divided by 11 to the power of 1 by 4. So we need to simplify this. How will we simplify this? Bases are same. It's divided, powers are different. We know that a to the power of m divided by a to the power of n can be written as a to the power of m minus n. Correct? Second one, a to the power of m divided by a to the power of n can be written as a to the power of m minus n. Correct? Here also the bases are same, powers are different. It is divided, so you need to subtract the powers by writing a common base. So I can write 11. Then 1 by 2 minus 1 by 4. Correct? 1 by 2 minus 1 by 4 in the power. That reason is a to the power of m divided by a to the power of n and written as a to the power of m minus n. This is the reason. Okay? So we write this as it is. It will simplify the power. You can observe that this is 2 and this is 4. Powers are different. So, denominators are different. What we will do? Either we will cross multiply, otherwise we can take the LCM, or we will take the common denominator. Okay, we will take cross multiplication. 4 into 1 is 4, 2 into 1 is 2, so 2 4s are 8. Correct? Cross multiplication method. Subtraction of rational numbers. We have studied that, right? Okay. 11. 4 minus 2 will become 2. In the denominator we have 8. So cancel in the power 2 ones are 2 4s are. So what is the remaining now? 11 to the power of 1 in the numerator, 4 in the denominator. So 11 to the power of 1 by 4. 11 to the power of 1 by 4 will be the answer for this. So that simplification should be there in the power. Okay, that simplification should be there in the power only. Bases are same, so that base we have done as it is. Only that simplification will be happening in the power part, exponent part. Okay. So we have the last one. So the last one is 7 to the power of 1 by 2 into 8 to the power of 1 by 2. Okay, 7 to the power of 1 by 2 into 8 to the power of 1 by 2. Here we have got that A into B to the power of M can be written as, sorry, A to the power of M into B to the power of M can be written as A into B to the power of M. Fourth, right? So this is also we have studied. You can observe that here bases are different, powers are same. Bases are different, powers are same. So we can combine the bases and we can write the common power because powers are same. Here it is multiply. Correct? But the same thing will not applicable for addition. Remember that. If I am having 7 to the power of 1 by 2, then plus 8 to the power of 1 by 2. Don't think that I can write 7 plus 8 to the power of 1 by 2. This is wrong. Because I am having a addition sign. Here it is multiplication operation. Here it is addition operation. Operation will plays a very big role. Okay. So when we are having a multiplication operation, we can combine that and we can write the common base. Even division also. A to the power like 7 to the power of 1 by 2, then 8 to the power of 1 by 2, then we can write 7 by 8 more to the power of 1 by 2. This also will do if it is division. If it is multiplication, then we can apply this law. When we are having addition and subtraction, this law will not be applicable. Remember that. Okay. So we will do this. So 7 to the power of 1 by 2 into 8 to the power of 1 by 2 can be written as 7 into 8 whole to the power of 1 by 2. Correct? A to the power of m into b to the power of m can be written as a into b to the power of m. The same law. Okay? A to the power of m into b to the power of m can be written as a into b to the power of m. So 7 8s are 56 to the power of 1 by 2 to the power of 1 by 2. So this will be the simplification. Or if you want to simplify for 56, you can do it. Whether it will be divided, whether it will be expressed in terms of 2, we will see that 2 2s are 4, 2 8s are 16, then 2 1s are 2 4s are, then 2 7s are. Now you will be getting a 7. So again, you will not be expressed only in terms of 2. So it's you can write 56 to the power of 1 by 2 itself. Okay. So that is the answer. So if it is expressed only in terms of 2, I can write 2 to the power of something. Say suppose in terms of 56, I will be having 8 in the sense. I will be writing 2 to the power of 3. So 2 to the power of 3 in the sense it will become 2 to the power of 3 by 2 if I combine those with the existing power. Okay. But it is not expressed in terms of 2. You will be getting a 7. So again, you will be having one more factor. So it's very difficult to write those two factors in terms of 1 by 2. Okay. So you can write 56 to the power of 1 by 2. So that will be the answer. Okay. So this will complete the lesson, number system. So I have given the homeworks also to complete that. So complete the homeworks whatever I have given. Okay. So what we have studied in the day 1 about the number system. Let us overview that. We have studied about the different number systems. What are the different types of number system we have, that we have studied that. Then we have studied about rational numbers. First we have studied about the rational numbers. Then how to find out the rational numbers between any two rational numbers, right? Then we are having how to represent the rational numbers in terms of p by q, correct? Then we are having irrational numbers. We have studied about what is irrational number, then decimal expansion of rational number as well as the decimal expansion of irrational numbers, how it is looks like. Decimal representation, the decimal expansion of rational number will be either it is a terminating or non-terminating with recurring. Then it is called as a rational number. So what is the irrational number? Decimal expansion. It should be non-terminating. It should be non-recurring also. Then only it is a irrational number. Then again, how to bring decimal expansion form into a p by q form, right? So that is also we have discussed. Then real numbers and decimal expansion we have discussed. Then operations on real numbers we have discussed. What are the operations we can able to do on real numbers? That is combination of both rational numbers and then irrational numbers. We have three conditions. Go through those three conditions, very important conditions. So that we have learned. After that we have learned about rationalizing the denominator. How to rationalize the denominator. Only the denominator, so that we have learned. Then we have studied about the law of exponents for real numbers. So how to use the law of exponents for the real numbers, that is also we have studied. So after completing this will complete the lesson. So I will give the time to read for tomorrow and day after tomorrow. Tomorrow we will do the test. Friday I will be conducting the test. So Friday I will be conducting a unit test for the number system lesson. Prepare for the lesson. We will conduct the test on the Friday. Okay. So time to any doubts you can get back to me. So you can call me or you can message me for the any doubts. Thank you.